Hey guys, and welcome to lesson 7.3, sketching graphs of rational functions. So what we're going to do today is basically follow a set of steps, which I'll briefly go through here, and those steps will definitely help us graph these rational functions. So the first thing is that we always have to make sure that we are factoring both the numerator and the denominator. And then once you've factored, you want to double check to see if there are any common factors that are between the numerator and denominator, because if there are, you're going to cross those out, and at those places we're going to have holes in our function. So we'll cancel the common factors and then work with the function that's left over. Then from what's left over, we are going to determine our vertical asymptotes, we're going to determine our x-intercepts, we're going to determine our y-intercepts, we're going to determine any other horizontal or other asymptotes. And then what we're going to do after that is use those roots and the vertical asymptotes. And then what we're going to do is create a sign line. And the purpose of the sign line is to determine where the function is positive and where the function is negative. And with all of that information, what we're going to do is sketch, and we'll be done. Make sure that you're doing all of your asymptotes with dotted lines, and you want to plot all of your x and y intercepts. The other thing that you should make sure that it's pretty visible on your function is the hole, if there are any. Okay, so we'll move on to the first example. So we have y equals x plus 5 all over x squared minus x minus 12. So from step 1, we need to factor. So nothing we can factor up top, but in the denominator, we can factor that to be x minus 4 and then x plus 3. So let's list all the key features of this function. So right now, because there are no common factors, we can't cancel anything out, so we have no holes in this function. We can check next for vertical asymptotes. Now, vertical asymptotes happen when the denominator equals 0. So I'm just going to focus on our denominator, and I see that when x equals 4 or when x equals negative 3, the denominator would be 0. Similarly, the x-intercepts, those come from when the numerator equals 0. So with the numerator, we see that when x equals negative 5, we will get a x-intercept. We can list our y-intercepts as well. The y-intercepts happen when x equals 0, so we'll definitely be subbing in x equals 0, and then we'll solve for y. So we have y equals, and then 0 plus 5, and again I'm using the factored form here. So 0 minus 4, and then that multiplied by 0 plus 3. So altogether, we're going to have 5 over, well, negative 4 times 3 would be negative 12. Okay, let's go back to our asymptotes. So we have a vertical asymptote at 4 and negative 3. We've already established that. Now we need to check if we have horizontal or some other kind of asymptote. Now, remember from the other day's investigation, when the degree of the numerator is less than the degree of the denominator, you automatically get a horizontal asymptote at y equals 0. Okay, so we've stated everything that we needed to state. Now is the time we create our sign line. And remember, on our sign line, only the x-intercepts and the vertical asymptotes go on the sign line. So our x-intercepts from above were negative 5, and our vertical asymptotes were negative 3 and 4. So obviously in order, I'm going to put those values in, negative 5, negative 3, and positive 4. And what I want to do is, similar to what we did a few units back, I want to find out the sign in each interval. Because that will tell me if my function is above the x-axis, if it's positive, and if it's below the x-axis, if it's negative. So we want to try some test values. So for example, anything less than negative 5, we can try x equals negative 6. And so what I'll do is, in that factored form from above, which is on the right side of the screen now, we're going to sub in the value x equals -6. So if I sub in x equals -6 in the numerator, clearly the numerator will be a negative number. And in the denominator, if I sub in -6, well, -6 minus 4 would be a negative number. And -6 plus 3 would also be a negative number. So in essence, we have 3 negative numbers altogether would make this whole entire thing negative. In the interval where x is less than -5, we know that our function would be below the x-axis because we ended up with a negative value here. Okay, so now let's check in between -5 and -3. So obviously, I think our best choice here would be to try x equals -4. And we'll do the same thing. So sub in -4, so -4 plus 5, that actually equals a positive value. And in the denominator, -4 minus 4, negative. And then -4 plus 3, also negative. So what we end up with here is 1 positive, 2 negatives, altogether combined would actually make a positive value. So anything in the interval between -5 and -3, our function will actually be above the x-axis. Okay, so now we're going to test in between -3 and +4. So my favorite value here to try is x equals 0 because I think that's the easiest. And in fact, we've already done that calculation. If we look at our y-intercept, we've actually subbed in x equals 0, and you can see that as a result, we actually end up with a negative value. And then finally, we'll pick a value that's greater than 4, so let's say 5. And then again, we'll sub in and see what we end up with. So in the numerator, 5 plus 5 is obviously a positive number, and in the denominator, 5 minus 4, and then 5 plus 3. So clearly all three values here end up being positive, so altogether we end up with a positive value. So now that we have all of that information, our x-intercepts, our y-intercepts, our vertical asymptote, horizontal asymptote, any holes, and the sine line, then now we can go ahead and graph. So I'll try and do a split screen here. Okay, so on our graph, we want to label, or we want to plot everything that we have. So there are no holes to plot, but we do have vertical asymptotes at 4 and -3. So I'll be putting those in with dashed or dotted lines. Okay, so 1 at 4 and 1 at -3. The next thing we're going to do is plot any x-intercepts that we have. So the one x-intercept that we have is at -5. So I'll plot that there. We have a horizontal asymptote at y equals 0, so at our x-axis. So I can plot that as well. And again, remember from yesterday's investigation that it's okay to cross a horizontal asymptote, but never okay to cross a vertical asymptote, because the functions don't actually exist at the vertical asymptotes. Okay, so the last thing we need to plug or plot is the y-intercept, which is -5 over 12. And if we actually calculate to that as a decimal, it's about -0.4. So we will plot that at -0.4, so somewhere in this area here. Okay, so the rest of our work comes from our sine line. Now notice that anything less than -5, so our x-intercept of -5, our function must be below the graph, because in this sine line here, we have a negative here. So I know that the function will be below the x-axis, but because we have a horizontal asymptote, I'm going to stay fairly close to it, because our function, as it continues off into negative infinity, will be approaching this horizontal asymptote. Okay, so now we take a look between -5 and -3, and if you look at our graph, -5 is the x-intercept and -3 is the vertical asymptote. Now, in between those two values, we know that our function is going to be above the x-axis because of the plus sign. So what I'm going to do is make sure that I am above the x-axis, but at the same time I want to approach the vertical asymptote. So we'll just get closer and closer to it and approach it. Wonderful. Okay, now in between -3 and 4, which happen to be the vertical asymptotes on our graph here, so everything between -3 and -4 must be below the x-axis. So the one thing that we do know is the y-intercept right here. So from this point towards this vertical asymptote of -3, I want to come close and approach it. And same as I go from this point to the other vertical asymptote. Always approaching the asymptotes. And then finally, anything beyond the vertical asymptote of -4 would be above the x-axis because of the plus sign here. So pretty much everything in this upper quadrant or this upper section here. So we have to think of two things. We have a vertical asymptote here and a horizontal asymptote here. So that part of the function needs to kind of approach both of those things. So think of it as starting way up top here. And as we get closer and closer to the x-axis, we approach the horizontal asymptote. Alright, so that is our first rational function. Let's move on and try another one with example 2. Okay, so again, we follow the steps. First thing that we have to do is factor. So I see common factor up top of 3x. We'll factor that out, leaving us with x plus 2 up top. And then in the denominator, we can factor that to be x plus 2 and then x minus 1. Now I notice that we actually do have a common factor here of x plus 2. So keep that in the back of our head because we know that there's going to be a hole at x equals -2. Okay, so this actually simplifies to just 3x over x minus 1. This is what we'll use to find our x-intercepts, y-intercepts, and so on and so forth. But actually, before we go ahead and do that, we need to define where the hole is. The hole is a coordinate. It is a point on the graph, and it has both x and y values. So right now, we know that the hole has a x value of -2. So to find the y value of the hole, this time what we're going to do is sub in x equals -2 into the simplified version of the rational function here. So the y value of the hole would be so we know that there will be a hole -2, 2. So that'll be something that we'll plot later on. Okay, so the same steps as last time. We need to determine where our vertical asymptotes are. And again, those come from the denominator. Looking at the denominator, I see that when x equals 1, we will get an undefined function. We need to list our x-intercepts. Those come from the numerator. And so when x equals 0, the whole numerator will equal 0. The y-intercepts, those come from when x equals 0. So if we subbed in If we subbed in 0, we actually get 0 over -1, which is just 0. And actually, what you should notice is that if you have an x-intercept of 0, then automatically your y-intercept will be 0, because that's the origin point. Okay, and then finally, any other asymptotes or horizontal asymptotes. So again, remember from the other day's investigation, when the degree of the numerator is equal to the degree of the denominator, which it is, we actually have a horizontal asymptote at whatever the quotient is of the coefficients. So we'll have a horizontal asymptote. So the coefficient of the numerator divided by the coefficient of the denominator. So 3 over 1, which is just 3. Okay, so once we have these 5 things, now we're ready to go ahead and make a sign line. And again, remember the only things that go on the sign line are the x-intercepts and the vertical asymptotes. So again, just to remind you, our function really is just 3x over x minus 1. Okay, so let's do some test values. Let's try anything less than 0, so we'll try x equals negative 1. When we actually go sub that in, 3 times negative 1 actually makes a negative number in the numerator, and in the denominator, negative 1 minus 1 is actually negative. So altogether, we end up with 2 negatives, giving us a positive value. In between 0 and 1, let's try x equals 0.5. So again, we'll sub in 0.5. 3 times 0.5 would actually still be positive up in the numerator, and in the denominator, 0.5 minus 1 is actually negative. So altogether, we end up with a negative value in that interval. And then finally, we'll try x equals 2. And in the numerator, 3 times 2 would give us a positive value, and 2 minus 1 would actually also be positive. So altogether, positive. So again, we'll take all of that information and use it to graph our rational function. Okay, so same as last time, we're going to plot everything that we know. We actually have a hole at negative 2, 2. So I'm going to represent the hole with an open circle. So that's our hole. We have an x-intercept and a y-intercept at 0, 0. We have a horizontal asymptote at y equals 3. And then finally, we have a vertical asymptote at x equals 1. Alright, so now that we have all that information, we can start kind of connecting the dots based on the information in our sign line. So anything from our x-intercept of 0 to the left of it, we know that we are going to have our function above the x-axis because of this plus sign. And in fact, actually the whole being up here also leads us to believe that our function to the left of this x-intercept must be somewhere above the x-axis. So we'll go ahead and start at our x-intercept and go through the hole. We won't actually draw a line through it, but we'll go through the hole, and then at this point we are going to approach our horizontal asymptote. Okay, and then anything in between 0 and 1, so anything between our x-intercept and our vertical asymptote is going to be below the x-axis. So from our x-intercept, I'll put my pencil and I will go below the x-axis, and at the same time we approach the vertical asymptote. And then finally, anything to the right of the vertical asymptote of 1 must be above the x-axis. So really the only way to guarantee that is if I am above this horizontal asymptote. Because if I drew a function down here, let's say, and again, don't copy this because I'm just going to show you just for visual purposes. A lot of the times on a test, I'll see this, that a student will do this. Yes, that part of the function is above the x-axis. But what happens over here? There's something missing. A line just doesn't come out of nowhere. It has to go somewhere. So in essence, what might happen is that it lends me to believe that this function will go down and approach negative infinity, which is incorrect because we know that everything to the right of the vertical asymptote must be above the x-axis. So I don't want to see any of this on a test. We'll get rid of that. Okay, so again, the only way to ensure that you're always going to be above the x-axis is to be above that horizontal asymptote. So we will be close to the vertical asymptote and approach the horizontal asymptote as x gets larger. Okay, so that's our second function. We move to example 3. So again, we will factor, and when we factor the numerator, we actually get x plus 4 and x minus 1. In the denominator, we get x plus 2, nothing to factor there. So we have no common factors, so when it comes to any holes in the function, there are none. We can state our vertical asymptote, anything that would make the denominator equal 0, So when x equals -2, our x-intercepts come from the numerator. So when x equals -4 or when x equals +1, our numerator would equal 0. We can work on our y-intercept now. We'll just sub in x equals 0. So 0 plus 4, 0 minus 1, and then 0 plus 2. So we actually end up with -4 over 2. And our y-intercept would be at -2. And then finally, we must deal with any other horizontal or other asymptotes. And remember from the investigation from the other day, when the degree of the numerator is larger than the degree in the denominator, then we actually end up with a slant asymptote. And to calculate the slant, we actually do the division. So we're actually going to divide x plus 2 into our polynomial up top. And the way that we can do that is to use synthetic division. So our divisor would be the x plus 2, so our root would be the -2. Then the coefficients of the numerator would be 1, 3, and -4. So we can go ahead and do the synthetic division. We'll drop down the first term, multiply, add them up, multiply, and add them up. And in fact, we don't even need the remainder. That gets ignored. So then this actually is our constant term, and this is our x term, and if we had more, we'd have x squared, and so on and so forth. So our slant asymptote is actually going to be the line y equals x plus 1. Alright, so now with all of this in mind, we are going to create our sine line. And again, x-intercepts and vertical asymptotes only. And just to remind us, our function is on the right of our screen here. So what I'd like for you to do now is pause the video and try it out on your own. I'll work through it and we'll see if we match up with the exact same answers. Okay, and when you are done all of this, we can actually go ahead and start graphing. Again, what I'd like for you to do is pause the video and try and fill in everything on your own and see where you end up. And I'll post the answer here, but we'll most definitely take it up in class tomorrow. Okay, and as always, if you have any questions, please make sure you ask in class, and we'll see you next time. Take care, guys.